Hi everyone. In today's video, we're going to be looking at cyclic quadrilaterals, or sometimes just called cyclic quads for short. But what is a cyclic quadrilateral? A cyclic quadrilateral is defined as a quadrilateral of four-sided shape, and all four vertices lie on the circle. So you'll see here, this is a vertex. A vertex are these things over here. These are vertices. And you'll see here, all four of these lie on the circle. So they all touch the circle. So you can see here we have this quadrilateral in the circle. So this is the definition of a cyclic quad. So with cyclic quads, we have three pieces of theory. First, we have that opposite angles are supplementary, or that they add to 180 degrees. Secondly, we have that the exterior angle is equal to the interior opposite angle. And thirdly, we have angles in the same segment are equal. Let's look at the first one. The first piece of theory says that opposite angles are supplementary. So our opposite angles are supplementary, or add to 180 degrees. So let's look at what are our opposite angles. If we look at angle A1 and we move across like this to the other side, you'll see that C1 is the opposite angle to A1. So we can write that angle A1 plus angle C1 give us 180 degrees. They're supplementary. But what we also have is angle D2. And what's opposite to angle D2 is angle B1. So we can write that angle D2 plus angle B1 give us 180 degrees. Good. That was the first part of the theory. Secondly, we have that the exterior angle is equal to the interior opposite angle. Let's break this down. So the exterior angle is equal, so it's equal to the interior opposite angle. So again, we're dealing with opposite angles. So let's have a look at what I mean by an exterior angle. So if we look, here's our cyclic quad again. It's this shape over here. This is our cyclic quad. But if we look over here, this is outside. This angle is outside our cyclic quad. So we call it an exterior angle. So D2 is exterior. And it says our exterior angle is equal to the interior opposite angle. So if we move over and we look at D, what is opposite to D? You'll see that B1 is opposite to D1. So that means that B1 is our interior opposite angle. So we can write that D2, because remember, D1 is the opposite angle, but it says here the exterior angle is equal to the interior opposite. So it means that D2 is equal to B1, because the exterior is equal to the interior opposite. So we only use D1 to check what's opposite. So if we continue over here, D2 is equal to B1. Let's try another one. If we look over here with C2, C2 is our exterior angle over here. So what is the angle that's opposite to this? We go over to C1 like this, and we look what is opposite to C1. And you'll see that A1 is opposite to C1. So that means that angle C2 is equal to angle A1. Good. The third piece of theory tells us that angles in the same segment are equal. This one's a bit more challenging in a way. It's not as clear as the first two. So let's have a look. Firstly, what do they mean by a segment? So a segment is created when we have a chord like this, which is just a line that doesn't go through the center of the circle. You see how we've created two parts or two segments. These are called segments. So our theory tells us that angles in the same segment are equal. So we know now that this top part over here is our one segment. But what we need to do now is we need to connect our vertices to the opposite vertices. So you see we have vertex A and vertex C. We need to connect these opposite vertices of our cyclic quad like this. And D is opposite to B, so we need to connect our opposite vertices. Okay, so when we do this, we'll get something that looks like this in the next slide, like this, with the dotted lines. So if we look at our theory, it says angles in the same segment are equal. So firstly, what I want you to notice is we have these funky little triangles over here. And these are related, these two triangles. We're going to have to use these triangles to find out which angles in the same segment are equal. But this looks familiar. At least to me, it looks familiar. This reminds me of Spider-Man eyes. Do you see the connection? We have these two triangles, this one and this one. And you see how they almost look like Spider-Man eyes. So this is what I often use to identify when we're dealing with angles in the same segment. So when we have this, we have to look at what angles are in the same place. So you see how in this triangle we have B1 is up here and C2 is over here. Do you see how these two angles correlate in these two triangles? So what we can write then is that angle B1 is equal to angle C2, because angles in the same segment are equal. What you can also do is, it's a bit more difficult to explain, but what you can do is, if you start at B, this vertex B, and we take our two fingers and we move the one all the way across till it touches another vertex. Then we take our other finger and move it across till it touches another vertex. So now our two fingers are at A and D. So I want you to almost put your fingers over the monitor or over your phone at A and D. Then what I want you to do is, now I want you to move across anywhere where we haven't put yellow. So do you see how we now have to move this way and this way until we get to C? Okay, so we started at B, we went all the way to A with our one finger and D with our other finger. So remember, you can move your fingers across the monitor. And then what we do is we moved across the sides we haven't moved. And you see how we ended up at C. So that's another way that we can use to check which angles are in the same segment and which angles are equal. Okay, I hope that isn't too confusing. I know there's a lot of drawing over here, so I'm going to get rid of some of it. But now let's look at what other angles in the same segment are equal. So if we go at A2 over here, we need to find what else is equal to A2. So you'll see that A2 is at the bottom of this triangle, and D1 is also at the bottom of its triangle. So we can write that A2, angle A2, is equal to angle D1. Okay, and again, we could have also done the method where we start over here, we move our fingers across this way and this way, and then again, we move our fingers across our sides. So you'll see that we start at A2 and we end up at D1. Okay, we end up at D1. So I hope that isn't too confusing, and I hope you guys understand. Let's quickly review the three pieces of theory that we just learned for cyclic quads. Firstly, we have that opposite sides are supplementary. So remember, they're not equal, they add to 180. So 180. Let me fix that. 180. Okay. Then secondly, we have the exterior angle is equal to the interior opposite angle. So be very careful, opposite angle. And thirdly, we have that angles in the same segment are equal. So I hope that video was helpful, and I'll see you guys in the next one.